Hello and welcome to the solution video to my 2025 AQA Practice Paper 2H. You can download a copy of this paper at my website firstclassmaths.com, and there's also a link in this video's description. I'd like to thank Casio Education for sponsoring these video solutions. In this first question, we're told that the probability of A is equal to the probability of not A, and we need to find the probability of A. You should know that the probability of A plus the probability of not A is equal to 1. For example, the probability that I win a game equals 0.7, then the probability that I do not win the game must be 0.3, since 0.7 plus 0.3 equals 1. So we're looking for two numbers that add to make 1, but they must be equal to each other, so that must mean that they're both equal to 0.5, and that's the answer to the question. In the second question, we're told that 2/3 of x is equal to 5.4, and we need to write down 2/9 of x. To do this, we need to think about how we get from 2/3 to 2/9. One way of doing this is dividing it by 3. If you divided 2/3 by 3, that will be the same as multiplying it by 1/3. And you can see here 2 times 1 is 2 and 3 times 3 is 9. So to go from 2/3 to 2/9, we divide by 3 or multiply by 1/3. So you can take 5.4 and either multiply it by 1/3 or divide it by 3. Both of them will give you the answer 1.8, which is the answer to the question. In this question, we need to factorize this expression. We'll start by looking for the highest common factor of the two terms, which are 8x to the 4y and 20xy to the power 3. The highest common factor of 8 and 20 is 4, so we can factorize out of 4. Then for the x to the 4 and the x, the highest common factor is just x. And for the y and y to the 3, it's just y. Now we need to consider what will go inside the brackets. What would we multiply 4xy by to get to 8x to the 4y? Well, to get from the 4 to the 8, we would multiply by 2. To get from x to x to the power 4, we need x to the power 3. And we've already got the y, so that's it. Then what would we multiply the 4xy by to get to 20xy to the power 3? Well, to get from the 4 to the 20, we multiply by 5. We've already got the x that we need, and to get from y to y to the power 3, we need to multiply by y squared. So this is the answer to the question. In this question, we need to find the nth term of a sequence. We'll start by finding the difference between each of the terms, which in this sequence is always plus 9. This means the nth term will start with 9n. We now write the 9 times table above the sequence and consider how we get from this to our sequence. To get from 9 to 40, you add 31, and that will work for 18 to 49, 27 to 58, and 36 to 67. So it must be 9n plus 31. In this question, we need to complete a table, and we've been given a formula for the population density. So let's start by working out the population density of Bermuda. To do this, we'll use the formula and take the population, which is 64,000, and divide it by the area, which is 50. If you do this with your calculator, you'll get 1,280. Next, let's look at the population of Jamaica. For this, we'll need to rearrange the formula. If we multiply both sides by A, then we end up with population density multiplied by area equals population. So to find the population of Jamaica, we multiply its population density by the area. The population density is 255 and the area is 11,000. If you multiply those together, you get 2,805,000. And finally, we need to find the area of the Bahamas. We'll need to rearrange the formula once again. Let's divide both sides by population density, and we end up with area is population divided by population density. So if we take the population of 406,000 and divide it by the population density of 29, we find the area must have been 14,000. So that's the table complete. In this question, we're told that on Monday, Robin throws a dart at a target 10 times, and 6 of his throws hit the target and the rest of them miss. We need to write down Robin's relative frequency for hitting the target on Monday. The relative frequency is a fraction, or a decimal, representing how many times he hit the target as a proportion of the total times that he tried. So since he hit it 6 times out of a total of 10 times, the relative frequency is just 6 out of 10. In the second part of the question, we're told that on Tuesday, Robin throws the dart 40 times. 27 of these throws hit and the rest miss. We're asked to write down the relative frequency of hitting the target for all of the throws on both Monday and Tuesday. So on Monday, he threw it 10 times and hit 6 times, and on Tuesday he threw it 40 times and hit 27 times. So in total across both of the days, he did 10 plus 40 throws, so that's 50 throws, and he hit 6 plus 27 times, so that's 33. This means the relative frequency of hitting across both days will be 33 hits out of a total of 50. In the final part of the question, we need to decide which of the previous answers is a better estimate for the probability that Robin will hit the target. So the previous answers were 6 out of 10 and 33 out of 50. When you're working with relative frequency, the one that's going to be a better estimate is the one with a greater number of trials, or in this case, a greater number of throws, which would be our answer to part B since he had 50 throws. The reason we could give then is this one has more throws. In this question we have some shapes, and we're told that the area of the trapezium is less than the area of the rectangle. We're also told the area of the rectangle is less than the area of the triangle. So let's start by trying to work out the areas of these shapes. You're told the area of the trapezium on your exam aid. It looks like this. A and B are the parallel sides, so that's the 12 and the 18. It doesn't matter which way round you label those, and h is the height, which is 4. So we now take the formula and substitute these numbers in. So we've got 1/2 multiplied by a plus b, which is 12 plus 18, and then multiplied by the height, which is 4. You can just type this into your calculator for this exam and you'll get 60. So that's the area of the trapezium done. What about the area of the triangle? Well, that's 1/2 multiplied by the base, which is 14, multiplied by the perpendicular height, which is 11. You can type this into your calculator as well and you'll get 77. Now remember that we were told the area of the trapezium was less than the area of the rectangle, but the area of the rectangle is less than the area of the triangle. This means the area of the rectangle must be in between those two areas, which we found were 60 and 77. Now in this question we've been asked to find two possible values for h, which we can see as the height of the rectangle, and we're also told it's an integer. Let's imagine we were trying to find the area of the rectangle. We would multiply the base, 12.5, by the height, which we don't know, it's just called h. Let's pretend for a second that this was equal to the lowest of our areas, so 60. What would the value of h be? Well, we can work this out by doing 60 divided by 12.5, which will give you 4.8. And if we did a similar idea for the other area of 77, we'd have 12.5 times h equals 77, and then 77 divided by 12.5 gives you h equals 6.16. This means that h must be in between 4.8 and 6.16. But remember we were told that h is an integer, which means a whole number, so it needs to be a whole number that's in between those two numbers. The only two whole numbers in between those are 5 and 6, so they must be the answers. In this question we've been given a graph and asked to find the roots of this equation. Since the equation of the graph here is exactly the same as the equation we're asked to solve, we can find the roots by looking at where it crosses the x-axis, which is in two places, here and here. We then just read off those x values and I make it x equals 0.6 and x equals 3.4. In the second part we need to find the equation of the line of symmetry. If we draw on the line of symmetry here, we can see it crosses the x-axis at 2. This means its equation is x equals 2. In the first part of this question, we're asked to write down the modal class. This is the class with the highest frequency. Looking at the table, the highest frequency is 22, which corresponds to the class between 0.12 and 0.14. So that's the answer, in between 0.12 and 0.14. For the second part of the question, we need to find the interval that contains the median. To do this, we'll first of all add up all of the frequencies to get the total. If you do this on your calculator, you'll find there were 80 sprinters. We then add 1 to this number, which gives you 81, and then divide this by 2 to get 40.5. This tells you that the middle reaction time is in the 40.5th position. So we just need to look down the frequencies here and keep counting on until we hit 40.5. The first group has 4 sprinters. If we include all of the next group, we've now got 26 sprinters, since 4 plus 22 is 26. If we add in the next group, we need to add 13 onto this, which is 39, so we're nearly at the 40.5th, but not quite. But if we add on the next group, we go all the way to 60. So we must have passed the 40.5th reaction time here, so it must be in this group, which is between 0.16 and 0.18. In the final part of the question, we need to work out the percentage of sprinters that had a reaction time less than 0.14 seconds. In the first group, the reaction times were between 0.1 and 0.12, so they are all less than 0.14. The second group is between 0.12 all the way up to 0.14, but notice it doesn't include 0.14, so all of those are acceptable as well. The next group goes from 0.14 to 0.16, so we don't want any of those. So we just need to add up these here and we'll find the number of sprinters that had reaction time less than 0.14. If you add these together, you get 26. Now it wants it as a percentage of all of the sprinters, and remember from before there were a total of 80 of them. So to write this as a percentage, we first write it as a fraction, 26 out of 80, but then multiply it by 100. Doing this on your calculator will give you 32.5, and that's the answer to the question, 32.5%. In this question, Zara has £2,500 to invest for 4 years, and we need to work out how much more interest she would receive by using offer 1 compared to offer 2. So let's take a look at offer 1, which uses simple interest at 6% per year. To work out 6%, we're going to turn 6% into a multiplier by dividing it by 100. So 6 divided by 100 is 0.06. This means if I multiply any number by 0.06, it will find 6% for me. So let's take 0.06 and multiply it by Zara's money, £2,500. This will find 6% as £150. So Zara is going to receive £150 each year. But remember she invests it for 4 years, so let's multiply that by 4. 150 multiplied by 4 is 600. So Zara will receive £600 in interest using offer 1. But what about offer 2? This one has compound interest at 4.5%. We need to find the decimal multiplier to increase by 4.5%. To do this, you start with 100% and then add on this 4.5%, which would of course be 104.5%. If you divide this by 100, you'll find its decimal multiplier, which is 1.045. We now take the amount of money that Zara has, so 2,500, and multiply it by this number, 1.045. This will add on the interest for us for the first year, but we need to do this 4 times for the 4 years, so we do it to the power 4. And that will give you this number here, which we need to round to 2 decimal places since it's money, so £2,981.30. Now this is the amount of money that Zara would have in the account, not the interest. So let's work out the interest by subtracting the original amount of money that she had. £2,981.30 subtract 2,500, which gives you £481.30. So we now have the two interest values. In offer 1 it was £600 and in offer 2 it was £481.30. To find how much better offer 1 was, we'd need to subtract those. So if we subtract them from each other, we end up with the answer £118.70. In this question, we need to use trigonometry to work out the value of x. We'll start by labelling the triangle. The hypotenuse is the longest side opposite the right angle. The opposite is the one opposite the angle in the question, so this one over here, and the adjacent is the other one. In this question, we have some information about the hypotenuse, it's 15, and we have information about the opposite as well, that's the x we're trying to find. There's nothing with the adjacent, so we'll lose that for this question. We then look at SOHCAHTOA and decide which one of these we want to use. Since we have the opposite and adjacent, we will use sine. So we write sine of the angle, which in this question is 39, is equal to the opposite, which is x, divided by the hypotenuse, which is 15. We can solve this equation by multiplying both sides by 15. On the left side, that will just be 15 multiplied by sine 39, and on the right side the 15s will cancel, so we're just left with x. If this is equal to x, then we can just type this into the calculator to find it. If you type this into your calculator, you'll get x is equal to this number here. It might make sense to round this off to a sensible number, so something like 9.4 or 9.44. In this question, we need to use Pythagoras' theorem to work out the value of y. When doing Pythagoras, you're going to square the two sides that you're given. So we need to square 2.89 and 1.61. The only decision we need to make is are we adding them or subtracting them. Since we're finding one of the two shorter sides of this triangle, we will subtract them. So 2.89 squared, subtract 1.61 squared. Doing this on your calculator will give you 5.76. Then to find the value of y, we just square root this, so the square root of 5.76, which is 2.4, and the answer to the question. For this question, we need to work out the equation of the line. To do this, we find the gradient and the y-intercept. We'll start with the gradient by picking 2 points on the line. It doesn't matter which points you pick, but I'm going to go for this point here and this point. It does make sense though to choose ones that are exact coordinates. We then draw a gradient triangle between these 2 points. The change in y is the vertical distance between the 5 and the 7, which is 2, and the change in x is the horizontal distance between the 1 and the 2, which is 1. We can then find the gradient by doing the change in y, which is 2, divide by the change in x, which is 1. And 2 divided by 1 is 2, so the gradient must be 2. I said earlier we also need the y-intercept, which is where the line crosses the y-axis, which is here, so that must be 3. We can now write down the general equation of a line, which is y equals mx plus c. But m is the gradient, which we found is 2, and c is the y-intercept, which we found was 3. So the equation of the line is y equals 2x plus 3. In this question, we need to find the reciprocal of a over b. If you have something written in a fraction like a over b, to find its reciprocal, you just switch the numbers round. So instead of a over b, it will be b over a. In the second part of the question, we need to find the reciprocal of c, and we're told that c is equal to the sum of a and b. The sum of a and b means a add b, so a plus b. To find the reciprocal of c, we would write c as c over 1, and then flip this upside down, so 1 over c. But we know that c is equal to a plus b, so instead of 1 over c, it's 1 over a plus b. In this question, we're told there are X students in Mr. Maiden's class and Y students in Mr. Vickers' class. One student is going to be selected from each of their classes to play a game of chess, and we need to work out, in terms of X and Y, the number of ways these students can be selected. Well, if there are X in Mr. Maiden's class and Y in Mr. Vickers' class, the number of ways is just X multiplied by Y, which we would write as XY. In the second part of the question, we're told that Mr. Maiden selects 2 different students from his class to win prizes. They'll win different prizes, so one of them's large and one of them's small. And we need to work out an expression in terms of x for the number of ways he can select the students. Well, if we think of the number of ways of selecting the first student, there are x students, so there are x ways. Then if we think about the number of ways of selecting the next student, it will be x minus 1 since the students have to be different. He can't select the previous student again. So x minus 1. Then we just multiply these together, so x brackets x minus 1. If you really want to, you can expand this bracket out, but you don't need to, so if you wrote x squared minus x, that's also acceptable. In this question, we need to enlarge shape A by the scale factor -2 with the centre -2, 2. The first thing we do is mark on the centre, so -2, 2, and then we pick a point on shape A. I'm going to go for this one here. To enlarge this with a negative scale factor, we start at this point and create a journey back to the centre of enlargement. So for instance, we could go down 1, then to the left 1. Now since it's scale factor -2, we repeat this journey back past the centre of enlargement 2 more times. So it was down 1 and then left 1, so we'll go down 1, left 1, that's the journey once, down 1, left 1, that's the journey twice. So this first point would map to here. Then we do the same for the other 3 points, so we'll do this one. We'll go back to the centre first, which is down 1, 2, 3, and then right 1, 2, 3. So we repeat this 2 more times. Down 1, 2, 3, right 1, 2, 3, that's once, down 1, 2, 3, and right 1, 2, 3. That's the second time, so that point maps to here. Then if we go for this one, we'll go down 1, 2, 3, 4, and then right 1, 2. So we do that 2 more times, down 1, 2, 3, 4, right 1, 2, down 1, 2, 3, 4, right 1, 2. So that point would map to here. And for the final point, it's down 1, 2, 3, 4, and then across to the right once. So down 1, 2, 3, 4, across 1, down 1, 2, 3, 4, and across 1. So that point would map to here. We then connect up these points, and that's your final shape. In this question, we're told the equation of the circle, and we need to write down the coordinates of the centre. If you have an equation of a circle in this form, x squared plus y squared equals r squared, then the centre is always 0, 0. In the second part of the question, we need to write down the radius of the circle. So if we take the equation of the circle and compare it to the equation I wrote down before, the 77.44 is the r squared. This means we can find r by square rooting this, so square root of 77.44, which will give you 8.8. So you could think of the equation as being written as x squared plus y squared equals 8.8 squared. So 8.8 must be the value of r and the radius of the circle. In this question, we need to work out the length of the side x. We'll do this using the sine rule. Let's label the side we're looking for as lowercase a, and the angle opposite that as capital A. Then the other pair that we have as lowercase b and capital B. We then write down the sine rule, a over sine A equals b over sine B, and we substitute in what we have. The value of a is x, the one we're trying to find, so x over sine of a, so sine over 115, equals b, which is 15, over the sine of b, which is sine 22. We then multiply both sides by the sine 115 to get x equals 15 sine 115 over sine 22. If you type this into your calculator, you'll find the value of x is this. The question wants the answer rounded to one decimal place though, so it'll be 36.3. For the first part of this question, we need to complete a table. We need to write down the types of sequences that sequence B and C are. If we look at the nth term of sequence B, we can see it has n squared, which means it must be a quadratic sequence. For sequence C, it's easier just to look at the sequence itself. You should notice that to get from one term to the next, we're always multiplying by 3, so 30 times 3 is 90, and so on. This means it's a geometric sequence. In the second part of this question, we're told about sequence D, which is formed by subtracting the terms of sequence A from the terms of sequence B. We need to find the nth term of sequence D. To do this, we'll take the nth term of sequence B, so n squared, and then we'll subtract from this the nth term of sequence A, so 2n subtract 5. So we need to do n squared subtract 2n subtract 5. Now it's really important that you put this second nth term in brackets because we're subtracting that whole thing. Now we need to expand this out, and if it's easier, you can imagine there's a 1 in front of this bracket here, so a negative 1. So we have n squared, then we do negative 1 times 2n, which is negative 2n, but then negative 1 times negative 5, which is a negative multiplied by a negative, so a positive 5. So the nth term is n squared subtract 2n plus 5. In the final part of the question, we have sequence E, which is formed by multiplying the terms of sequence C by 4. And we need to find the nth term of sequence E. So let's take the nth term of sequence C, which is 10 times 3 to the power n, and multiply this by 4. Here we can just multiply the 10 and the 4 together, which is 40, so we have 40 multiplied by 3 to the power n, which is the answer to the question. In this question we have two similar cones, and we've been given some information about them which we can actually just see on the diagram. We've been asked to work out the volume of cone B. We have the formula for the volume of a cone, which is 1/3 pi r squared h. Pi r squared is just the area of the base of the cone, so the circle, and we actually have that for both of the cones. We just need to find the height of cone B, which is the h, so this here. Since we have both of the areas, we can work out the area scale factor. So if we do the large area, 162, divided by the small area, 50, we end up with 3.24. So this is the area scale factor. Since we're trying to find the height, which is a length, we need the length scale factor. You can find this by square rooting the area scale factor. So the square root of 3.24, which is 1.8. So the length scale factor is 1.8. Now since we have the height of cone A at 16.2, and we have the length scale factor now, we can divide this by 1.8 to find the height of cone B. So 16.2 divided by 1.8, which is 9. So the height of cone B must have been 9. Now that we have the height, we can use the formula for the volume. It's 1/3 multiplied by pi r squared, which is the base area, which we can see is 50, and then multiplied by h, which is the height, which we found is 9. If you type this into your calculator, you'll get 150, which is the answer to the question. In this question, we're asked to work out the proportion of runners that ran at an average speed greater than 2.5 meters per second. So we've been given the speed at 2.5 meters per second, and we're told in the question that everybody runs for 12 minutes, which is the time. And you can also see the histogram is about the distances that were travelled. So we need to use the formula speed equals distance divided by time. If we multiply both sides of this by time, we end up with speed times time equals distance. We know the speed of the runners needs to be greater than 2.5 meters per second, and the time for all of the runners is 12 minutes. It makes sense to convert this 12 minutes into seconds though, since the speed is in meters per second. To do this, we multiply it by 60, so 12 times 60 is 720 seconds. If somebody ran at exactly 2.5 meters per second for 12 minutes, then we could work out the distance they travelled by doing distance equals speed, 2.5, multiplied by the time, 720. Doing this on your calculator will give you 1,800. So someone running at 2.5 meters per second will run a distance of 1,800 meters. We need to look for runners that are running faster than this, which will have therefore travelled more distance than this. So we're looking for all of the runners that ran more than 1,800 meters. To do this, we'll draw a vertical line at 1,800 meters on the histogram. We then need to work out the frequencies for all of the bars to the right of this. To work out the frequency from a histogram, you're finding the area of each of the bars by multiplying the frequency density by the class width. Let's do that for this bar here. We have a frequency density of 0.28 and a class width of 750. If you multiply these together, you'll get the frequency, which is 210. If we then look at this bar here, which has a frequency density of 0.76 and a class width of 250. Multiplying those together will give you 190. And then for this part of the bar here, which is everything to the right of that dotted line, the frequency density is 0.6, and the class width goes from 1,800 to 2,000, so that's 200. If you multiply these together, you get 120. So we now know the total number of people that ran a distance greater than 1,800, and therefore a speed greater than 2.5 meters per second. If we add all of them together, we get the total 520. We need to give this as a proportion of the runners though, so we need to write this as a fraction of the total number of runners, which we're actually told right at the start of the question. There are 1,000 runners. So there are 520 out of a total of 1,000, and that's the proportion. You're welcome to simplify this answer, but there's no requirement to do so in this question. In this question, we've been asked to show clearly that the large box must be better value for money. We've been given information about the mass, which is to the nearest gram, and price to the nearest 10 pence. Since the information's been given in this way, we know this is going to be a bounds question. So let's write out the error interval for the mass and the price of each of these boxes. Let's start with the mass of the small box, which is 320 grams. Since this value is given to the nearest gram, let's go a gram below and above 320, so 319 and 321. The error interval will then be halfway between these points, so 319.5 and 320.5. This means the mass of that small box must be in between 319.5 and 320.5. If you do the same sort of calculation for the large box, you'll find the mass of the large box is in between 799.5 and 800.5. Now what about the price? Let's do the price of the small box, which is £1.50, or 150 pence as I'm going to write it. Since this is given to the nearest 10 pence, we'll go 10 pence above and below this, so 10 pence below is 140 and above is 160. The error interval will then be halfway in between these, so 145 and 155. So we know the price of the small box must be in between £1.45 or 145 pence and £1.55 or 155 pence. Doing the same idea for the price of the large box, it will be in between £3.45 and £3.55. Now we need to think about how we calculate if something's better value. One way of doing that is to take the price and divide it by the amount. Let's do this for the small box first of all, and consider trying to make this calculation as large as possible. If we wanted to make it as large as possible, we'd take the largest possible price, so the maximum price, and divide it by the smallest possible amount, so the minimum amount. The largest possible price for the small box is 155, and the minimum amount is 319.5. So we will divide those. 155 divided by 319.5, which gives you this number here. The unit I've used here is pence per gram. Since this is the amount of pennies you'll have to pay for 1 gram of that cereal. If we now do this calculation again, but try and make it as small as possible, we'd need to switch things around. We'd want to do the minimum price, divide by the maximum amount. The minimum price of the small box is 145, and the maximum amount is 320.5. So if we divide 145 by 320.5, we get this number here, once again in pence per gram. This tells us that if we do this value calculation for the small box, then the value must come out between these two numbers here. Let's do the same idea for the large box. So we'll do the maximum price, divide by the minimum amount first. The maximum price of the large box is 355, and the minimum amount is 799.5. If we divide those, we get this number here. Now let's switch this around and try and make this calculation as small as possible. So the min price divided by the max amount. The minimum possible price is 345, and the maximum amount is 800.5. Dividing these will give you this number here. So this means the value calculation for the large box must be in between these two numbers here. Now remember, for this question we're trying to show that the large box must be better value. We can do this by comparing this number here, which is the maximum possible calculation we could have done for the value for the large box, with this number here, which is the minimum possible answer we could have got for the value calculation for the small box, which means the large box must be better value. So we might conclude by writing something like 0.4440 is less than 0.4524. It's worth noting two things in this question. Firstly, we didn't actually need to work out the other two numbers, 0.4851 and so on, and 0.4309 and so on. The two key ones are the ones that are highlighted. Secondly, there are many different ways of approaching this in terms of the calculations and numbers that you do. You don't have to do it in pence per gram. In fact, you could turn this calculation around and look for the amount divided by the price. I'm not going to run through all of the different examples for this, but as long as you make a similar comparison, you will be able to get all of the marks. In this next question, we have a charger which charges at 8 amps, and the time it takes to charge is t minutes. We're told that t is inversely proportional to the square root of a, which means we can write down a formula. T equals k, which is some constant, divided by the square root of a. We're also told that Alexander uses a 1.44 amp charger to charge his phone in 60 minutes. We can substitute these values into the formula. T will be the time, which is 60, so we have 60 equals k, this constant that we need to find, divided by the square root of a, so the square root of 1.44. The square root of 1.44 is 1.2, so we have 60 equals k over 1.2. If you multiply both sides by 1.2, 60 multiplied by 1.2 is 72, and on the right hand side these 1.2s will cancel, so we have k. So we found that k is equal to 72. We can now substitute this back into the original formula here, so it's t equals k, which we now know is 72, divided by the square root of a. And that is a formula connecting t and a. In the second part of the question, we're told that Graham has a 2.25 amp charger and a 2.56 amp charger. We need to work out which of these chargers will charge his phone faster and by how many minutes. So let's take the formula from the previous part of the question and substitute in these values for a. So let's go for 2.25 first. T equals 72 divided by the square root of 2.25. If you type this into your calculator, you'll find that this is 48 minutes. If we do the same calculation for the 2.56 amp charger, then it's t equals 72 over the square root of 2.56, which will give you 45 minutes. So we can see that the second one charges faster, and to find out by how much, we'll just subtract the times. So the answer is the 2.56 amp charger charges faster by 3 minutes. In this question, we've been asked to work out the length of AC. We've been told the ratio of AB to BC is 2 to 3. So it makes sense to label AB as 2x and BC as 3x. We've been told the area of the triangle is 163. In this question, we'll need to use the formula for the area of a triangle, 1/2 AB sine C. Let's label up the triangle. We'll label one of these sides that we have as A and the angle opposite that one as capital A. The other side that we have as lowercase b and the angle opposite that capital B. And then the other pair is lowercase c and capital C. I appreciate that this might be slightly confusing, especially since the corners of the triangle are labelled as A, B and C. But those are purely labels and don't help us with this question at all. The reason I've labelled it in the way I have is to ensure that capital C is the angle that we have in this question. We can now use this formula, which is area equals, but we actually know the area, we're told that was 163. 1/2 multiplied by lowercase a, which we said was 2x, multiplied by lowercase b, which is 3x, and then multiplied by sine of capital C, so sine of 75. The first thing I'm going to do is multiply both sides by 2. On the left-hand side, 163 multiplied by 2 is 326. On the right-hand side, the reason I've multiplied by the 2 is to cancel out the half, since 2 times a half is just 1. So we're left with 2x times 3x times sine 75. Now on the right-hand side, let's multiply 2x and 3x together. So we have 326 equals 2x times 3x is 6x squared times sine 75. Let's rewrite this equation the other way around, so 6x squared times sine 75 equals 326. And then we can divide both sides by 6 sine 75. On the left-hand side, that will cancel the 6 sine 75, so we just have x squared. And on the right-hand side, you'll need your calculator to do 326 divided by 6 sine 75, which will give you this number here. We can then find x by square rooting both sides to get x equals the square root of this number, which will give you this value here. So x is equal to 7.500000387. Now, if we use this x value, we can find the lengths of AB and BC. AB is 2x, so if we double this, we get 2x, which is this number here, and if we triple it, we get 3x, which is this number here. So we now know the lengths of AB and BC. In this question, we're asked to find the length of AC, which is the other side. We can do this using the cosine rule. We're going to relabel the triangle once again, but in a slightly different way. This time we'll label the side that we're looking for as lowercase a, the angle opposite this capital A, and the other two you can actually label any way you like, so we'll have lowercase b and capital B, and lowercase c and capital C. We then use this formula here. So we have a squared equals b squared plus c squared, so our numbers of 22.5 and so on squared, plus 15.0 and so on squared, minus 2 times b times c, so minus 2 times 22.5 and so on, times 15.0 and so on, and then times cos of a, so cos 75. If you type this whole entire right-hand side into your calculator using those exact numbers that we found, you'll find that a squared is equal to this number here. We then square root both sides of this, so a is equal to the square root of this, and if you do that on your calculator, you'll get this number here. The question wants the answer to one decimal place, and that will be 23.6. In this question, we need to solve an equation. Inverse f of x is equal to g of x. Notice we have g of x in the question, but we don't have the inverse function for f, so we need to work that out first. To do that, we take the function f and write it as y equals 6 over x minus 1. We'll then swap the x's with y's and y's with x's, so instead of y equals, it's x equals, and instead of x minus 1, it's y minus 1. We now need to rearrange this to make y the subject. To do this, we'll multiply both sides by y subtract 1. On the left-hand side, that'll give us x lots of y subtract 1, and on the right-hand side, this y subtract 1 will cancel, so we just have 6. On the left-hand side here, we can expand out the brackets. X times y is xy, and x times a negative 1 is negative x. And the right-hand side is 6, of course. Now we can add x to both sides. That'll cancel the negative x on the left to give us xy, and on the right-hand side, 6 plus x. And then we divide both sides by x. On the left-hand side, that'll cancel the x, so we have y, and on the right-hand side, 6 plus x divided by x. We can now replace y with the inverse function, so the inverse function is 6 plus x over x. We're now ready to solve the equation. So if it's inverse f of x, which is 6 plus x over x, equals g of x, which is given in the question, that's 9 minus 2x. To solve this, we'll multiply both sides by x first. That will cancel the x on the denominator on the left-hand side, so we have 6 plus x. And on the right-hand side, we'll need to multiply all of this by x. So we'll have x lots of 9 minus 2x. If we leave the left-hand side alone, but expand out the right, x times 9 is 9x, and x times negative 2x is negative 2x squared. This is a quadratic equation, so we want to get all of the terms on one side. Let's get them all on the left-hand side by adding 2x squared to both sides first. If we add 2x squared to both sides, we'll create a 2x squared on the left-hand side, and of course we still have this plus 6 and plus x, but that will cancel the negative 2x squared on the right, so we just have 9x. We can now subtract 9x from both sides. We'll have 2x squared. We subtract 9x from the 1x that's already on the left, so negative 8x, and then we have plus 6, and the 9x on the right-hand side will have cancelled, so we get 0. All of these terms have a common factor of 2, so we can divide both sides by 2. 2x squared divided by 2 is 1x squared, negative 8x divided by 2 is negative 4x, and 6 divided by 2 is 3. 0 divided by 2 is still 0. Fortunately, this quadratic equation will factorise, so we can factorise it into x subtract 3, x subtract 1 equals 0, which gives you two solutions, x is equal to 3, and also x is equal to 1. So there are your two answers, x equals 3, x equals 1. Finally, I just want to say that if any of you are going on to do A-level maths next year, then make sure you check out the brand new Casio FX CG100, the perfect tool for mastering A-level maths. If you'd like to find out more, there's a link in the video's description. Thank you for watching this video, I hope you found it useful. Make sure you subscribe so you don't miss out on my future videos, and I'd really appreciate if you would like, comment, or share this video.